I guess we could start. Hello. My name is Igal Edry. I'm a program manager in the Windows Server organization. I've been, during the development of Windows Server 2012, I was responsible for the development of this, what we internally called hosted cloud scenario, which is about building clouds using Windows Server 2012. So what we are going to talk about is how Windows Server, the platform, helps you build efficient clouds, how you architect the lower level of this cloud infrastructure. We'll talk a lot about network, about storage, about how you connect the Hyper-V host. I've heard people saying in previous sessions that this sounds like a Hyper-V talk, and Hyper-V is the base for the private cloud. So we'll talk about Hyper-V a lot. We'll talk about the cloud infrastructure a lot. This will be very much Windows Server focused. So we will talk about that as the cloud infrastructure. And what I will try to convey here are the considerations that you should go through and think about when you are designing your cloud infrastructure. This talk is really intended to help you design the right grounds of your cloud that you're building, your private cloud, or if you're a hoster, it's still your cloud, right? It may be a public cloud, but your cloud infrastructure and how it looks like, what considerations you need to think about in terms of workloads, in terms of storage, networking, resiliency. And then we'll go one step further and actually show you a few representative configurations that we've built at Microsoft as part of the development of Server 2012 that are intended to light up the right feature set and also intended to help you understand which features can be combined with which features. Because I'm sure by now you have realized that Server 2012 has tons of different features in different areas that will help optimize network, storage, hardware usage, etc. And putting all of those together may not be trivial. So the purpose of this talk is really to help you put it all in the right place, understand how it fits together, and give a few representative configurations that you can go and then do yourself at home and play with it. And all of the configurations that I'll be talking about here are already publicly documented on the Microsoft website, so there will be a link at the end so that you can actually go and do this yourself. Sounds right? Okay. So when we started designing Server 2012, we said it has to be the cloud operating system. It has to be optimized for the cloud. And optimizing for the cloud means, for us, three things. It has to be multi-tenant. You don't build the cloud for a single tenant. Even if it's a private cloud, you end up running multiple departments on this cloud, and you probably are going to need to dynamically place those tenants. Sometimes you actually have even isolation requirements between those tenants. So multi-tenancy was key. Then it has to be high scale, and we have to drive the cost down, right? That's what the cloud is about. You build a large compute infrastructure. You build it at scale, and then you start running workloads on that. And the lower you can drive the cost down, the better, right? So high scale at low cost. And then, because you're going to have so many servers in your private cloud, it has to be really manageable, and being able to run a large number of servers in an automated way is critical, which is where PowerShell comes in. And it has to be extensible, because there is no way we can end up satisfying all of the requirements by everyone. So we also had to make sure that it's extensible so that people, either you or ISVs, can come in and add the necessary pieces of specific functionality that you might need. So we thought about these three, and we ended up with a long list of features, a long list of things we need to do to enable building clouds. So these are kind of bucketized by these three pillars. For multi-tenancy, we have features like network virtualization, like isolation at the switch, ability to provide quality of service for VMs and for host traffic, for the actual Hyper-V traffic. We have to be able to measure what's going on. Everything needs to be dynamically movable, so live migration, storage migration. You have to enable hybrid cloud scenarios, so enable connecting from your private cloud to some public cloud out there. All of these features come in the bucket of multi-tenancy, building a cloud. It has to run on any cloud infrastructure that you may end up building. So in this talk, we'll actually see that all of the kind of configuration choices we'll make will still enable those things to happen. So you'll still be able to run network virtualization on them. When you don't, when you make specific choices that would preclude that, I'll point them out. So I'll help you figure out what trade-offs are you making, okay? On the right side, it's your right? So on the right side, it's the manageability. And again, it has to be manageable regardless of which cloud infrastructure you end up designing. You have to be able to automate everything. Has anyone been in the session that I gave yesterday? Just one. Okay, so a few. So in that session, we actually automated deployment of one of the configurations that I will show you here. We'll actually use that one specifically to walk through how it looks like. But we automated that with PowerShell from zero to everything working with just one script. So obviously, the script did a lot, but it means that you can actually automate everything. And one of the reasons we've built this script, we had two reasons for that. We wanted to provide a sample, so to show you how it's doable, but we wanted to prove to ourselves that it's doable. And while you are developing a complex product like Windows Server, and I don't know how many different teams, each contributing their own piece to the technology, we actually had to make sure that at the end it all comes together and you can automate everything in a consistent way. And that's the second reason why we've actually built those scripts, to prove it to ourselves. So once this is manageable and extensible, extensibility is part of the Hyper-V extensible switch. We'll just take a quick look at that later. But after you've realized that you want to have this multi-tenant and you have to be able to manage the whole thing, now let's talk about how you actually build the architecture, how you build the actual building blocks of this cloud in an efficient way. And here we talk about three different things. We talk about the compute, the network, and the storage, right? And in the compute front, we've invested a lot in making Hyper-V much more scalable, run larger VMs on larger hosts, support more memory, support larger clusters, everything that you need in order to build a bigger cloud, a much more scalable cloud. So that's on the compute node. On the networking, we took an approach that says we will get to scalability by improving the code, obviously, but also by taking advantage of the latest modern hardware innovations out there. So whenever we can offload a network processing task to the NIC, we will do that. And what we get as a result is that we free up CPU cycles to run actual VMs. That's what you really care about, right? Not about the network processing. You want to run as many VMs as possible on a host. From a network perspective, this meant for us, let's use the NIC acceleration technologies as much as possible. That was kind of the theme. And then on the storage, we also went and focused very much on how you make it more cost-effective. And you've probably seen features like storage spaces, thin provisioning, copy offload, ODX, in SAN support, running Hyper-V over SMB for standard file shares for the case where that's the storage that satisfies your needs, allowing you to connect VMs to fiber channel SANs. All of that stuff basically meant that we will be also better at connecting to storage, better in terms of performance, and better in terms of lower price. So what we'll do in this talk is mainly focus on this central bucket and understand how this feeds into the design of your building blocks for the private cloud. Just to set the context right, I took this from the data center reference architecture guide that we have at Microsoft, and it kind of takes the holistic view of what it means to build a cloud, and it means to have some infrastructure in place, it means to have some software to manage it, it means to have some processes around and exposing those services to the customers. Where we are today is here. We are at the infrastructure. That's where we'll focus. We will not go to the other layers. So we will really be talking about Hyper-V and how it connects to network and how it connects to storage. Okay, so now that we got that done, let's start talking about the different design choices and then go to the actual configurations. Feel free to ask questions during. It can be as interactive as you make it. I'm happy to answer questions during the slides. We will have more slides than demos. I think that I couldn't figure out a way to make an architecture talk demo heavy. So this will be more about slides, but I'll try to put some demos in place in the right locations, and hopefully this will work out for you as well. Okay, ready to start? So, you've seen this list of features, and if you are like me, the first thing you want to do is enable everything and get the benefit of everything, and it's really cool and dandy, and you start trying to put all of the features together, and then you realize that it's not going to work like that. You have to make some choices. You have to build your cloud based on your requirements, and you have to make a lot of decisions about what are you going to use and what are the implications for how you're going to run this cloud, how it's going to be architected, etc. Again, the purpose of this talk is to help you make those trade-offs, and you'll see that you actually end up with a very, very compelling story with several options that you still have to choose from. I will try to help you understand how to choose. A lot of it is not purely technical. It can end up being choices that are based on how your organization is built, what you've traditionally been used to do, if you have existing investments. When it's technical, I'll help you understand the trade-offs. Where it's not technical, I'll try to help you understand that as well, but obviously there is some subjective decisions to be made when you're designing your cloud infrastructure. There is no one right answer that, that's how to do it and that's it. Simply there is none. So, usually when you start to think about designing your clouds and what are your requirements, you think about high availability and cost and scalability requirements, what's your performance needs, what are your security considerations. When you think about it further, you end up really focused on 4 key areas of considerations. You need to think about the workloads. What am I going to run on the cloud? Does this impact my design choices? Do I know what I'm going to run on my cloud, or is it completely general purpose and I need to design for this general purpose case, or am I designing something for a specific workload that I know about? You need to think about your networking infrastructure. How is the network going to be built to support your workloads requirement and your cloud requirements? You need to think about storage, and in storage we'll see that there are actually a wide range of choices to be made where the decisions there are often very much subjective and driven by organizational structure, driven by existing investments you may have already. So we'll talk about that, but storage is a key requirement. And then you need to think about resiliency. And what is my resiliency approach to building my cloud? What is the SLA that I'm going to offer to customer, and therefore, how does the infrastructure need to support that? So these 4 key areas are the areas we'll focus on when we'll dive into how am I designing my cloud. Let's start with the workloads. Okay, so the first thing you need to decide, and this is your choice, your decision, when you're building your cloud infrastructure is, am I building that to run kind of the infrastructure as a service, run anything, support any workload, or am I going to assume that the apps are going to be rewritten, redesigned, adjusted, made cloud ready and cloud aware? If you think about Azure made with the PaaS offering an assumption that everything is going to be rewritten, right? And the design of the cloud was done in a different way to support that. Different requirements around resiliency, because it's not an infrastructure resiliency anymore. A lot of different choices to be made here. When we think about building private cloud, we usually think about designing it to run any workload. So we will be focused here really on that aspect. You want to run any VM. Basically, we had a goal in Windows Server 2012 that no workload should stay physical, or I would say the other way around. Every workload can be virtualized. If you choose not to virtualize, that's fine. But there is nothing that shouldn't be virtualizable. And we've made a lot of decisions and a lot of investments to make sure that this is indeed possible. So we took the approach of workloads is anything. We don't know what it is. I want to be able to run on this private cloud any workload that I get. Which means that as an admin, you end up managing those VMs and those servers and not necessarily abstracted applications. Also works well with the approach of infrastructure as a service. As the IT department building a private cloud, you are managing the infrastructure and you're either letting your customer manage the VM, or maybe you're managing it for them as well, but you're still very much in the VM space of management, right? So that's one. The second is, what do I do in terms of performance for my applications? Are there specific requirements that will impact the way I design my cloud infrastructure? And here you really end up with a simple choice. Unless you have a specific requirement for a specific workload that you know about, then going with the industry standard 2-socket servers is usually the best ROI. The one place where this won't work is if you need servers with large number of CPUs. We've shown, I think, like 640. We're supporting 640 virtual CPUs, VMs with large number of vCPUs and large number of large memory sizes. Those are for the specific cases, right? If you are building a virtualized environment to run a very demanding workload, you'll do that. But if you're building a general purpose cloud, you'll probably be using the standard servers, standard number of CPUs, optimized for the best ROI. So only do the larger servers when it makes sense in terms of workloads requirement. Sometimes it makes sense. I've heard hosters telling me that it makes sense in terms of space consumptions of the server, power consumption of the server. All of that feed into the cost, right? But from the server perspective, best ROI is 2-socket servers. Another consideration around workloads is workloads that have a highly demanding network requirements. If you want to virtualize SQL, that's the most common example. Then things like SRIOV would allow VMs to have much better network throughput by simply connecting the VM directly to the NIC. But you have to have a NIC that supports that, right? So you will use SRIOV in the cases where you have demanding workloads that need it. There are actually trade-offs to be considered there. If you use SRIOV, you lose some other functionalities, and we'll talk about that. You may want to build a cloud that has different kind of servers so that you can place every workload in the most suitable server, so you can do that. And then the last thing you need to think about is the trust of the workloads, the trust you have on the workloads. In an enterprise environment, private cloud environment, usually a trust environment, you can make some decisions and design decisions that assume trust. In a hosting environment, very different. When I talked to some hostels in the customer visits that were part of designing 2012, one of the favorite quotes that we got out of that was from a hoster who said, I have to worry about the evil outside, and then I have to worry about the evil inside my cloud. I don't know what's running. I have to assume all the time that the VMs in my cloud are going to be hostile, and therefore I will design around that. So you should think about that when you do the design. So that's workloads. You understand what you want to run. You understand how the VMs are going to look like. We will make an assumption that we are building for the kind of every VM, every app. We don't have to rewrite anything. Just run VMs on my cloud for any app that I have. And let's talk about networking. So in the space of networking, you really have to think about 3 things. One is my isolation requirements, and we'll talk about different approaches for isolation. The other is what kind of infrastructure am I building? What's my fabric? Is it Ethernet? Is it 10 gig Ethernet? Is it InfiniBand? That kind of decisions. And then which NIC offloads are relevant for me? Which one do I want to light up? Which means which hardware do I want to buy, right? To take advantage of NIC offloads and therefore do better networking, better performance, lower CPU cycles, free up cycles for my workloads, right? So those 3 things are key. Let's talk about traffic isolation. How many of you are running Hyper-V today? Yeah. Okay, great. How many of you are running Hyper-V? Let's do this way. How many of you have in the Hyper-V server less than two or less NICs? No one. Okay. Around 5? 5, 6, kind of? Okay. More than 5? Few. And some have Hyper-V, but with no NICs, I guess, because you didn't vote, right? So it's a very standalone environment. In the I've actually heard someone tell me this week that he has 12 NICs in each Hyper-V server. That was, I think, the highest I've ever heard. 5 to 6 is actually the recommended best practice for 2008 R2. We basically say that. And the reason we say that is because there are different traffic flows running on the Hyper-V server. And in 2008 R2, we said each of them should be on a separate NIC, isolated. Some end up doing it on VLANs, but the most common practice, and I think we've kind of seen it here, is people follow those recommendations and have 5 NICs. Those traffic flows could be separated into 2. You have the virtual machine traffic, which is your tenants, right? That's the VM traffic. Your customer or your internal department, when they're moving workloads to your cloud, are using the infrastructure to run their traffic, right? And then everything else is kind of your traffic. It's the traffic that is Hyper-V owned. It's the data center traffic. It's the thing that you do, right? So understanding these traffic flows this way will help us kind of steer our decisions around networking one of 3 options. And will feed into this decision about how many NICs do I need on a server. You may want to still have separate NICs for each traffic flow, just like you did in 2008 or 2. You may do this because you have an existing investment, right? That's your servers. You want to just upgrade to 2012. You don't want to go and buy additional hardware or new hardware. You don't want to try to move to a different network fabric. You can still do that. That's fine. Then you can say, I'm in a kind of untrusted relationship between me and my workload, and therefore I will separate my data center traffic from my tenant traffic. There are actually other reasons to do that other than just trust, but separation of data center traffic from tenant traffic is something that we hear often as a reasonable design choice that people make, and it's not always purely technical. It's often coming from philosophy around it, but it is a very reasonable design choice, and actually we think this is probably going to be the most common one. And then in 2012, because we have all of the isolation features and quality of service features in place, you can actually run everything on a team of 2 NICs if you wanted to. So, or like 1 if you don't want high availability. So you can route everything through a single NIC or a single team. You can separate the green from the blue, or you can still separate everything from each other. Your choice. The features that will enable you to do this kind of consolidation are the port ACL within the switch, the quality of service, both at the host level and at the switch level, features like DCB to offload this quality of service throttling to the NICs. All of those features will help you enforce isolation, get performance guarantees, regardless of which choice you make. Okay? Then the next thing comes up, which is which network do I actually use? Which network infrastructure do I use? The big new thing in the industry right now and in 2012 as part of that is the support for 10 gigabit Ethernet. If you think about the move to consolidate all of those NICs into a single one, obviously there is the physical isolation aspect, but there is the bandwidth aspect. I just need bandwidth, right? And I may end up having multiple 1 gigabit NICs because I need more than 1 gigabit throughput of traffic. 10 gigabit allows you to consolidate everything together, get great performance on an Ethernet traffic, so you're familiar with it. I believe you've seen the demos for RDMA or SMP Direct, right? Anyone missed the keynote with the 1 million IOPS? So we've used that. We have a quality of service with DCB support in those 10 gigabit Ethernet NICs, right? And basically, you will see that all of the innovation, the hardware innovation, are happening on the 10 gigabit Ethernet. So that's kind of the future of Ethernet. You can move there. You can consolidate on top of a 10 gigabit Ethernet. Then there is InfiniBand, which allows you to go into even higher throughputs. It has RDMA support built in. But it's a different kind of network management, and it's a choice you need to make. It's usually lower cost than 10 gigabit Ethernet, but it means you have to change a lot of your infrastructure. Your choice. We support that. And then, for many workloads, you can still live with the 1 gigabit Ethernet. That's fine. Like, you may not need these new advances in network technology, and just continue to use 1 gigabit Ethernet, or you may have the existing investments. And we've seen customers who came from 2008-02 to the world of 2012. Suddenly, you can consolidate everything on a single network, which is great. But they have a lot of 1 gig Ethernet NICs and a lot of switches, and they end up teaming many of them together. And because we have NIC teaming now in the box, and we support teaming out up to 32 NICs, I've seen customers teaming together 8 NICs and just creating that as their network fabric. So lots of different choices to make here, but you have to make the decision about the technology you want to go with. Let's talk about hardware offloads. So there are many. How many of you have been in the network overview session? I think Sandeep gave that one. Okay, and he was talking about many different NIC acceleration features, right? What I'll try to show you here is where each of these NIC acceleration feature becomes relevant, because each of them is usable for a different case, right? So let's start with DCB. DCB here basically allows, what we've done with it in 2012 is to allow you to offload quality of service processing down to the NIC. You can set up, the reason you do that is if you're running live migration and management and storage, all of this on the same NIC. Here I separated them, but just to emphasize the point next. But if you're running everything on the same NIC, you want to still guarantee that live migration gets enough bandwidth guaranteed to actually successfully perform live migration when you want to, or storage gets enough bandwidth. DCB will allow you to do that in the hardware. So you'll set up policies for what's my minimum bandwidth that I need for each of those traffic flows, and DCB will do that at the hardware level. RDMA is specific for storage in the case of, in the implementation we have in 2012. So it's only relevant for fast access to file shares, SMB support, that's it. It doesn't provide any value in different cases. So you'll need RDMA support on the NICs that are connecting your Hyper-V servers to your file servers. If you're not going to use Hyper-V servers connecting to file servers, RDMA is simply not relevant for you. Okay? We have additional features like RSC and RSS, features that basically increase scalability of processing of network traffics, relevant very much on the host side to accept incoming traffic flows and process them in a more efficient way. VMQ is kind of the equivalent of RSS, but for VMs. So process a lot of network traffic and basically split the processing across the CPU cores. You don't have one CPU core, right? You have multiple these days. And what VMQ does and RSS does on the physical side is basically split the processing of incoming traffic across those CPU cores that you have instead of having one that dispatches everything to everyone. So VMQ is relevant just on the NIC that is connected to the vSwitch and then connected to the VMs. It's not relevant on the other side. You can do IPsec task offload. Again, this is a NIC, a VM supporting feature. You can have, if you have a VM that needs to do IPsec, you can offload that to a NIC so that all of the IPsec encryption and IPsec processing will happen at the NIC level, only relevant at the NIC that is connected to the vSwitch and connected to the VMs, not relevant elsewhere. Last but not least, SRIOV. Remember this technology that allows you to basically connect the VM directly to the NIC and bypass everything in the middle. You get very high throughput as a result. You bypass the switch, you bypass all of these mechanisms. So specifically, when you bypass the switch, this means that if you have any technology, any extensions on the switch, SRIOV will not be applicable to them. If you have NIC teaming, which is not hardware feature, but you can team NICs in Windows Server 2012, right? If you team NICs here, SRIOV bypass that as well. So you have to make sure that you use SRIOV in the cases where you need it. You get great throughput, but remember that it bypasses practically everything because it lets the VM directly talk to the hardware. So the whole stack of Windows Server in the middle is not relevant in this case. Which brings us to this basic trade-off between flexibility and raw performance, especially when you talk about NIC offloads. you need to be aware of what is the implication of that design choice that you've made. If you want maximum flexibility and you want to use the extensible switch with actual extensions and network virtualization and teaming and all of that stuff, then there are two offloads that you need to be careful about, and those are RDMA and SRV, because both of them have this nature of bypassing the stack in order to get better performance. RDMA on the file access side, SRV on the VM side. So be careful about that. Know that this is a per NIC. So you can have a dedicated NIC in the box with SRV just for the VMs that needs it, and then another NIC without SRV connected to the switch and have all of the flexibility in place. But when you have a VM connected to SRV, or when you have the Hyper-V SMB stack talking to an RDMA server, you bypass a lot of the stack of Windows. So be aware of that. Let's talk about storage. As I said before, storage has a lot of almost religious about it. People talk about it, and a lot of different arguments will fly around. It's not always purely technical. That has been my experience. Actually, it didn't come from the storage space before. I used to think that, hey, you can resolve almost any conflict by doing a logical analysis of the problem and understanding which one is better. And it turns out that in the storage space, this is not the case. So you obviously have the cost performance, which is kind of factual, right? You can measure how many dollars you pay and how much performance you get in return. That's doable. But then there is the block versus file, which is kind of a choice of the application of what it's need and what you're used to. And how do you manage these servers? How do you manage the storage? Do you have separate groups managing storage versus same people managing storage and network and compute? Create a very different design decisions. Some people have just vendor preference. I work with that one, and he has only blocks, so I'll do that. And that's fine as well. Or you may have existing investments, so even if you decide to move to something else, you have to do it in a gradual way so that you continue to leverage the investments you already had made. And then there is one thing that I think is even kind of go through this flow and impacted by almost anything here, which is what's the approach I have for scaling my storage. And there are basically two approaches. And I think they're tied to the organizational structure of how you're used to work. And some of them are tied to like beliefs, and some of them are logical, so I'll try to kind of put an order here. So basically the two approaches are, I scale my compute and storage together. When I add capacity to my private cloud, I add nodes with storage in them, and that's how I grow. And then there is the approach of, I want to separate those and grow each on a separate axis. I want to add compute when I need more compute or more CPU power, and I want to add more disk space and more storage when I need more storage. And with 2012, we allow you to actually do both. We allow you to do both, in a new way with storage spaces here and with file servers here. And obviously, the kind of traditional options were Hyper-V with just directly attached storage inside it. Well, it means that you grow both together, right? Or Hyper-V servers being added when you need them, and SAN controllers, SANs being added when you need them. So we kind of look at this as the two extremes, and there are different reasons why people would choose one over another. We allow you to do both of them. And again, I think that I always get, it's always difficult to explain, is there a better choice here? Because there is none. It's really a lot up to you. You have to make a choice of what fits your organization, your style, your requirements in a way. So if you want to use like the same storage for multiple Hyper-V servers, then obviously you're in this side, right? You have to. Or if you have a different group that's managing the storage and a different group that's managing your Hyper-V servers, then also you're in this side, because you want to give each of them control over its own piece of the data center that it controls. If you are a smaller organization, you would often be here because you don't have this organizational structure. Or if you are kind of just building self-contained unit with storage in them, and like each of them is designed for one specific thing, and you don't need to share storage between Hyper-V hosts. You'll be in that side. Both are valid. So the storage scaling approach will have an impact on what storage you will end up working with. Okay, let's talk about resiliency. And resiliency is really about one question. What happens when my hardware failed, right? That's it. That's what you plan for. You obviously think of which hardware might fail and make decisions based on that, where you want to put resiliency. Or you may go to the extreme and say, I don't care about hardware failure because as a private cloud infrastructure guy, I am going to assume that the application will take care of that. The application will be resilient for failure. So if a server fails, the application has another instance running elsewhere, and that's fine. So those are kind of the two extremes. The two extremes are, one, I will build every resiliency possible to handle failure. I will use Hyper-V failover clustering. I'll put dual NICs. I'll put dual power supplies. I'll obviously have a cluster, so I'll put like 2 servers, right? I'll double my storage, which is kind of not here, but I will make sure that the application isn't meant to be designed to handle failure itself, and I will do the best effort I can to handle failure at the infrastructure level. That's approach number 1. And approach number 2 says I will actually build a much lower cost infrastructure, but I will start making assumptions about either things will not fail or application-controlled failure can take place, either because the application is aware of it or because the application will use guest clustering, or even because I don't have an SLA that requires high uptime, right? All of these are reasonable reasons to go with this approach, which end up being much lower cost, right? And often people come to us and say, we want to build a cloud, it has to be 5 nines. Okay, so let's do the math, and they realize how much 5 nines is going to cost them, and then they go down to 4 nines, and you end up in the place where you feel comfortable about what's the SLA you want to offer, right? But those are the two extremes of the resiliency approaches you have. The nice thing is in 2012 is that we've made this one much lower cost to build. The shared storage that is required for Hyper-V clustering can now be regular file servers, so that makes it easier. Invested in all of the other features of resiliency. NIC teaming is in the box, so we've made it lower cost to do that. You can still do that. Both are valid. Azure is kind of like that. Amazon is kind of like that, right? Azure has a layer on top that will actually move a VM if it fails. We'll run it on a different host. It kind of replaces the Hyper-V failover clustering, but in a different way. And there are assumptions about the application in some cases, and there are assumptions about the amount of downtime that is acceptable. So the large clouds, like the huge clouds, are usually built that way because it really drives the cost down, but there are some trade-offs to be considered as a result. For enterprise cloud, this is the de facto standard, right? People build enterprise cloud with resiliency in the infrastructure. We are a utility. That's a very common statement. We can't assume anything about the workload. We have to run everything, and we are expected to provide resiliency, and therefore we do. So that approach is kind of more common in the private cloud space. Okay, so let's get into the specific examples. As I said, we've built it at Microsoft at the EEC, the Enterprise Engineering Center, and we've built them during the process of developing 2012 because we wanted to make sure that we understand how to do it so that at this day when we actually get to give it to you, we will be able to guide you how to use it. And it's not trivial. It's especially where you have a product at this size with different teams. I don't know if you know how Microsoft is organized, but we have the networking team doing its own things and storage team doing its own thing. And actually we have 2 storage teams, and the clustering team doing its own thing, and the Hyper-V team is doing another thing. And when you try to put it all together during development, you find a lot of issues. So we started very early and actually started building that to make sure that we are hitting the vision, the thing we want to have, which is to enable you to build private clouds. So we've built these at the Microsoft EEC, worked with partners, created a lot of guidance. So you have links here for specific step-by-step guidance of how to set up those environments, as well as samples of how to do it with PowerShell. And we've used hardware that we have at the EEC, like Dell servers, Mellanox NICs for testing RDMA, Emulix NICs, a mix of different hardware that we had available and worked with partners to get. Sorry, it doesn't mean that this is the only supported hardware, obviously, just that's what we've built on, okay? And we started by saying, let's first make sure that we know how to do the traditional thing, that it still works, and let's see what the benefits are that we are getting, even if you're sticking to the traditional way. So the first config we had was, let's build a cluster with separate NICs for everything, but let's take advantage of new features. The new features that becomes relevant here are SRIOV for VM traffic acceleration, right, which bypasses the switch, if you remember. 10 gigabit Ethernet on the storage side, which is actually, again, very common when we talk to hosters, customers, and we ask, where are you moving to 10 gig? The storage side is the first one that always comes up. That's where you need the extra bandwidth. The last one is actually the tenant, because especially in the case of hosters, that's internet connected, so you don't need 10 gigabit Ethernet to connect to the internet, right? But in a private cloud, that would be different. So we separated that, and basically you end up having a very traditional thing, but with NIC teaming and DCB and RSS and ODX on the storage side as scalability improvements. So you can actually get benefit from just even keeping your existing configuration, but moving to the modern operating system and modern hardware. In some places, you get better support, better scale, better resiliency. And then better scale and resiliency for the VMs, again with VMQ and NIC teaming on the switch side, or with the quality of service between VMs and using switch extension, using network virtualization on that side. The one thing to remember again is if you enable SRIOV, you bypass that. The specific two things that always come up with SRIOV are NIC teaming is lost and network virtualization is lost. If you're planning network virtualization, you cannot do that on a workload that is using an SRIOV NIC. For NIC teaming, that's actually doable by teaming in the guest. So you can have two SRIOV NICs exposed to the VM and use NIC teaming there. That's fine. So you can still do that. So I think this configuration is kind of straightforward. I couldn't figure out anything to demo here that would be interesting, so let's move on to the next ones, because the two next ones are really the new ones, the interesting ones of Server 2012. So this is the one that we kind of call Greenfield, and we say, hey, if you are designing a cloud that is designed to be optimized for the capabilities in 2012, and you have no constraints, you are starting from scratch, then probably this is the thing you want to build. And it does make one assumption, which is your approach to scaling storage and compute are to scale them separately. Because if you want to scale them together, we'll get to the next configuration. I want to do a quick survey here. On this approach of storage, how many of you have storage completely separate from your compute nodes and being managed by different groups, different teams? Okay, kind of, I think 80%. The others have it combined? Like, if you have it combined, raise your hand. Yeah, okay, 80-20, roughly. That's what we usually see, and that's why we think that this will be more natural for most people to move to. But again, the other option has some significant benefits, so think about it. We think that this one is really cool, and we've specifically with the RDMA support between Hyper-V and file server, it's both lower cost and also very performant to actually use. So let's go through that a little bit. So one thing is, when we started, we said that we can have different storage as the backend for the file server. But the really interesting case is where the storage in the backend of the file server is actually SAS-connected disks, right? If you have a SAN already, front-ending that with the file server made sense for some people, but probably not the most common case, right? What does make sense is to have SAS-connected disks, use storage spaces to pull those disks together, to create a space on them or virtual disk, to create a cluster shared volume. Notice that this cluster shared volume is on the file server cluster, not the Hyper-V cluster, right? So create a cluster shared volume, run a scale-out file server on that cluster, expose it as a share, and then you have basically a very low-cost file server storage that is available for the Hyper-V server to be used. So storage spaces lower the cost. There is another option. How many of you have seen the cluster in a box, either in a talk here or on the expo floor? Some, right? So the cluster in a box is a solution coming in from partners to actually create this whole cluster with the storage connection in one box. And one of the options there is to use clustered RAID controllers, very specific for a specific vendor, but what it means is that in that case, these RAID controllers basically replace storage spaces, right? That's what they do. They do the functionality that storage spaces can do in box, but in hardware, and it's an option for you to do. And then last is you can still connect it to a backend SAN. The most common reason I hear people telling me that they will do that is if they want to completely shift to a file-based storage instead of block-based storage, but they have block-based storage available, so they kind of use the file server to convert that into a file-based. Otherwise, I don't think it makes a lot of sense, but it's definitely doable. You can expose the LAN to the file server and then use CSV and scale out the face and make it into a file share, file access device. Let's talk about the Hyper-V side of things. On the Hyper-V side of things, we have the different traffic flows all converged through, right now it's a single NIC, right? So management, traffic, cluster traffic, live migration, all are routed through this NIC to your data center network. So know that your network architecture in this configuration is, I have basically just two networks, the tenant network for VMs and the data center network for my data center traffic. So if you route all of these through one, let's say 10 gigabit Ethernet here, then you have to also use QoS policies to guarantee the right minimum bandwidth for each of these traffic flows. Otherwise, you may end up in a case where maybe some large storage access is starving live migration, or worse, starving cluster traffic, and cluster heartbeat is lost and stuff like that. So you use QoS to do to guarantee minimum bandwidth. And if you have in the 10 gigabit Ethernet, you have DCB support, QoS at the OS level will just tag the relevant traffic flows, but the actual quality of the actual throttling would happen at DCB at the hardware NIC level. Just to avoid confusion, I have this here. It's not completely relevant to the architecture of the cloud here, but there are two QoS mechanisms in Windows Server 8 that people get confused between. There is this OS QoS, the parent partition quality of service features, and then we have QoS at the switch, which basically allows you to set up minimum and maximum guarantees on each switch virtual port, and that's the switch QoS. Both of these functionalities are manageable only through PowerShell. Some of it is in the UI, but mostly you use it through PowerShell. So those are the relevant PowerShell feature. QoS at the OS level is this net QoS policy. Switch at the QoS at the switch level is with the set VM network adapter with the minimum bandwidth parameter there. And if you want to enable DCB, you have to set to do some specific things to enable the offloading to happen. Now we want to introduce high availability, right? Resiliency, we decided we want to have double of everything. We want to introduce high availability, so we put in NIC teaming in place. Everything looks fine except one thing. When you do that, remember RDMA bypasses a lot of the stack, right? Which means if you put in NIC teaming, RDMA will actually not work. like NIC teaming wins in this case. So NIC teaming hides the fact that the NIC is RDMA capable from the SMB stack, and therefore if you do NIC teaming, you will not leverage RDMA functionality. You will use 10 gigabit Ethernet with teaming, but no RDMA. So that's a kind of a tough trade-off. And some people would solve it by just adding another NIC for RDMA and for SMB traffic, but there is actually a neat configuration you can do instead of NIC teaming, which is to use the fact that both SMB and cluster traffic and live migration can all leverage multiple NICs for their functionalities, right? So you can say SMB has SMB multi-channel support, so it can actually do the equivalent of NIC teaming by finding that there are 2 RDMA NICs enabled and go through both of them without NIC teaming, right? Cluster, you can say both networks are marked for allowing cluster traffic. Live migration, again, you can enable 2 networks for live migration. And if you do that, you can end up with redundancy as well as RDMA enabled. But just to remember, if you are using RDMA, then probably NIC teaming here is not the right thing to do. You lose RDMA. But there are workarounds. Let's do a short walkthrough of how a configuration like that looks like. Okay, so this is the cluster that we've actually built on stage yesterday using PowerShell. It started with nothing. It has 4 servers. They're called HC Demo 1, 2, 3, and 4. They're all server core in this case. And what we've done yesterday was take these 4 servers, which were plain vanilla Windows Server, and configure them to be this file server-based config that we just showed you using PowerShell. So let's just take a look at a few of the key points here. So we have, and what I'm doing right now, another thing to note is that I'm actually running on a Windows 8 client. I'm using the RSAT, the Remote Server Administration tool that I installed here, and I'm running failover clustering from this client machine that I connected to server core because, let's face it, UI is nicer than PowerShell, right? The intention of PowerShell is to enable automation, but when you want to kind of look at the thing, UI works, right? So I'm connecting through UI to servers that are actually server core that have no UI there. And what I have here is the storage cluster, so the file server cluster. It is running the role of scale-out file server. The scale-out file server exposes 2 shells, VM share and VHD library. We created 2 shells, one for the running VM and one for the library of VHD that you want to provision there. It has, in terms of disk, it is using storage spaces. So let's take a look at this one. It is actually connected to a lot of SAS disks in the back end, right? So we've connected, I think 24 or something like that, SAS disks to this file server. We've pulled them all together into a single pool. We've created 2 shares or 2 clustered shared volumes, 2 clustered shared volumes, and then 2 shares on top of that. So these are these ones. And again, this is now running as a scale-out file server with these shells, right? Now let's go to the Hyper-V side of things. I think I actually have a VM running there, yeah. So this is my Hyper-V cluster. It has 2 nodes, HC Demo 1 and HC Demo 2. It doesn't have any disks, right? Because it's using the file server for the disk space. Networks, we didn't look at that. So we have one network, which is this hoster net, which is actually teamed. You don't see the team here, right? We'll connect to that in a second. And now, if I go to the Hyper-V manager, so let's connect to the Hyper-V manager. If I go to the Hyper-V manager and just connect to one of them, you'll see that the Hyper-V server is configured to use this scale-out file server, the VM share for the VMs. Actually, I think there is a misconfiguration here. It was supposed to be VHD share and VM share, but okay. And it's allowing the use of the live migration network. And what I wanted to do more is to connect to the actual server. Let's see if I can do it here without. Okay, so this is my server core, right? And if I do a get net adapter, you'll see that I have hoster, like two teams there. Hoster net 1 and 2 are teamed together to be hoster net, and tenant net 1 and 2 are teamed together to be the tenant net. And if I do that, you will see that I have these two teams. Tenant net is configured over tenant net 1 and 2, etc. Right? So we have two teams. We have a Hyper-V cluster connected through the hoster net to the file server. The file server is using a file. Using SAS disks, create a pool, create a share, and that's the configuration, and that's how it works, right? And there is a step-by-step on how to do that, and there is a PowerShell on how to configure that, right, available for you. Okay, so that was that config. Let's talk about the next option. And the next option goes with the approach of scaling compute and storage together, and let's just put everything into a single cluster. Let's not create a separate file server cluster. Instead, let's have the Hyper-V cluster be directly connected through SAS to JBods, and let's play with that. We also made another choice here, which is let's also not separate the network traffic of VMs from the hosters. Let's do this in software with Windows, but let's not have physical separation. So this is what we come up with. You end up with a simpler cluster in a way, right? You actually don't have to. You have less servers in the smaller case. When you grow, it kind of becomes less relevant. But when you are building a small cluster, that makes a lot of sense. You can actually scale that up, and we've built clusters like that. We actually have a cluster running at 64 nodes, which is the maximum size of cluster you can have. Obviously, in that case, not all of the disks are connected to all of the JBods. Not all of the nodes are connected to all of the JBods, but you can grow that out as well, scale it out. But this is the configuration we had, and let's take a look at that a little bit. So first thing is we route all traffic through the vSwitch, right? Because you don't have separate NICs for live migration and for the tenant network. So you basically end up creating management OS switch ports on the vSwitch. And now, you end up, and now you have to configure cross policies and ACLs so that everything is secure in this configuration. And all of the functionalities to actually enable that is built into 2012. So VM NICs are created, right? ACLs are set, right? Cross policies are set, but it's all routed through the switch. In order to do that, in this configuration, you actually have to put each of these on a separate VLANs. You didn't have to do it in the previous config, but here you basically have to do it on separate VLANs so that each of the VLANs is mapped to a switch port. And you run spaces here on the Hyper-V host, and all you need is create the pool, create the space or the virtual disk, and create a cluster shared volume that's available on the Hyper-V server. You don't need the file server role. You don't need to create shares because it's basically all local, right? It's a cluster shared volume. So no need for that. Someone told me at the booth yesterday that he thought this can't be done because you can't run file server role on the Hyper-V cluster, which is the fact that you can't run a file server role on a Hyper-V cluster is true, but you don't need to do that, right? Because you just have the CSV here. One thing to note is that in this configuration, a lot of I/O redirection will end up happening between the hosts. And this I/O redirection, and the reason it will happen is because although this cluster is completely symmetric, so think of this, there is SAS connection between the disk and the second host as well, right? But the way Spaces is designed is that for each volume that we'll create on the disk, a single node will be nominated to own the I/O to that volume, right? So if node 2 wants to connect to a volume that's kind of owned by node 1, there will be I/O redirection happening between them. And if you have the requirement for the high throughput that RDMA can provide, then you might want to actually add a NIC here for just for RDMA traffic or for CSV traffic between the nodes. Again, you end up maybe having 2 and all of that kind of considerations, but just important to note. Let's take a look at that. You have to change resolution whenever you connect to a projector here. Makes things less trivial. Okay, so I think I actually did, yeah. Okay, so config 3 is our cluster that looks like that. What I'll do here is I had cluster manager running here. Yeah, okay. No. Okay, so this is my cluster. Note that it has 3 nodes in this case. I think we've been continuing to playing with it at the EC while this is happening here. So we have 3 nodes participating in the cluster. We are using a pool with a number of SAS disks connected directly to the Hyper-V server, right? And so that's my cluster shared volume. If I go to the Hyper-V Manager console, Hyper-V Manager, here it is. And I do the same thing I did before, which is look at the Hyper-V settings. You'll see that my storage is on the CSV, right? It's not any share, just mapped to the CSV. And then the other thing that's worth noticing is that if we open PowerShell, okay, we have many NICs. Some of them are disabled, but we have noticed the VNICs that are basically on the VM switch, right here. We can look at the VM network adapter or the vSwitch configuration and see that we have actually, on this converged switch, that's the name we've given him, we have 3 management OS traffics, or 3 management OS both, sorry, defined, one for cluster, one for live migration, one for management. They actually have VLANs associated with them. I think I noticed a misconfiguration yesterday that the last one is not VLAN tagged for some reason, but you have, for each of those networks, you have a VLAN tag associated with it. And one more thing to notice is that once you do that kind of config, and you go to look at the switch manager, and I look at the switch, you'd notice that most of the UI here is disabled. And that's because from a UI perspective, we only support 1 management OS. If we detect that you've done these kind of additional things, we'll turn off the UI so that you don't mess up with it. And you are actually in the PowerShell domain now. Okay? So Hyper-V cluster directly connected to SAS disks, using cluster shared volume, right, for running it, and network all converged through the same switch. Okay. So that's the second one. Very appealing. First of all, very innovative, right? It's a new thing you couldn't do before. There wasn't even a theoretical possible to do it before 2012. Very low cost. You drive everything into a single cluster that can manage its own storage. Very performant. Does scale well because, as I said, we've actually built it in a 64-node cluster. We're in the process of working on the numbers and releasing performance information about that and specific guidance on which hardware to use for the best performance, etc. So we are doing that. But it's a different approach that is also kind of greenfield for Windows Server 2012. If you're going to build your cloud from scratch and you don't have the need to separate storage from compute, then that's an approach to consider. I thought just for completeness, because you can't do that without that. You obviously can do that, right? You can use DAS storage and not SAS, so like SATA disks inside a Hyper-V node. That kind of maps to the non-clustered approach where resiliency is the responsibility of the application. But obviously you can do that. That's a very simple Hyper-V cluster, Hyper-V server, sorry. The one new thing here that you should note is that even in this configuration, you can do live migration. So remember we said on every configuration you have to have multi-tenancy, dynamicness, the ability to balance the load. You can now do live migration between standalone Hyper-V hosts. You don't need to have a cluster for live migrations. So even if you build that, you can still move your VMs around. You can obviously move storage around, so storage migration will also work here, and that's a really cool thing. So, in summary, we've made Windows Server 2012 very much cloud optimized, lots of focus from the beginning. There are different cloud architectures that will fit different needs. There is no one size fits all. So I hope I was able to kind of show you the different options, the different trade-offs you need to think of. I hope I was able to show you some of how to choose between them. I think some of it is still work in progress, and we're actually working ourselves on articulating the reasons why each choice could be better than others. But then again, it's also clear that there is no one single answer. So a lot of this is your decisions, your subjectives, kind of requirements that will come into play. In all of the architectures, so first of all, we've made sure that we support the existing architecture, so it's easy to migrate, easy to transition to 2012, but there are new architecture that will be more efficient and will allow you to do new cool things. All of the guidance is available out there, so the links are there. And I didn't talk about System Center at all, but I just want to make sure it's clear that what I've just shown here is not the cloud, right? It's the cloud infrastructure, and you really want to go and then use System Center to actually manage it all. But regardless of which configuration, which architecture you choose for the infrastructure piece, then System Center can add the management capabilities on top of that, put VM, move them around, even provision the hosts for you, right? So you don't have to do this yourself and manage it all. So System Center 2012 SP1, because that's the version that supports Server 2012. And it's currently in CTP 2, and it's available publicly. There are additional sessions you might want to go to. The T of the Twitter is kind of misplaced, but you can follow me on Twitter. You can find me later, either here or over email. My email is eagle.edry@microsoft.com. There are configuration guides that are available on the web. And I think with that, I will open up for questions. And thank you. Any questions? Nope. Okay, I'm here if you want me. Thank you.